Hey everybody, today we're going to talk about the greatest integer function, commonly referred to as the floor function, and then we're going to also talk about the rounding up function, which is commonly referred to as the ceiling function. Both of these are step functions because you'll see graphically that they look like steps. So let's talk about the question of today, the $1,000,000 question. How can you model a function that can only take on integer values? So let's talk about that. The greatest integer function is denoted by f of x equaling the greatest integer of x for all real numbers x. The greatest integer function returns the largest integer less than or equal to x. In essence, it rounds down a real number to the nearest integer, which is bizarre. This is the rounding down function. Now, this does not seem too practical until you put it into a real life scenario. Say, for instance, you're very hungry, you see the golden arches, you know that you got that great dollar menu at the Golden Arches. So you decide that you're going to get the McDouble. That's the one, the McDouble. So remember, the McDouble is $1, right? Our McDouble's $1. Well, you only have $1.50. Now, I can use the greatest integer function to model how many McDoubles you can get. Let's look at this. So here's your pockets. I know my McDouble's $1, okay? I can say, hey, the greatest integer function is equal to f of x, or the greatest integer of x, and I denote that by brackets. Another way that I can write the greatest integer function is because I'm going to be rounding down, I can denote the brackets going down like this. All right, so when I see this, I am going to say, hey, what is the greatest integer of my $1.50 that I have in my pocket? Well, if I think about that, the greatest integer of that $1.50 that's in my pocket, rounding down, I can only get one McMuffin, right? Or one McDouble, not McMuffin, one McDouble, right? Now, say I had $2.75. Well, if I had $2.75, again, would I be able to get, no matter how hungry I am, would I be able to get three McDoubles? No, I wouldn't be able to get three McDoubles with my 275. Okay, this is rounding down. I would only be able to get two McDoubles. So notice the greatest integer function, or the rounding down function, takes every value that you have and it rounds down to the nearest whole integer. Okay, so it rounds down to the nearest integer. What you want to pay attention to when we're using the greatest integer function are negative values. The tricky thing here is that we're going down to we're rounding down. So we need to make sure that we're going down when we're thinking negative values. And sometimes we got to remember the number line. So if I talk about evaluating the following values, walk through these with me and remember the number line. We're rounding down. So what is the greatest integer of -3? Well, the greatest integer of -3 is -3. Okay, I'm just going to the next whole integer, which is -3. Let's go to the next one. What is the greatest integer of -1.2? This is when I have to think about it. I'm rounding down to rounding down to the next whole integer. That would not be -1. Okay, -1 is bigger than -2. That would be rounding up. So really, the greatest integer of -1.2 would be -2. Pay attention to your negative values. Remember, you're rounding down. What's the greatest integer of -4.7? I'm rounding down. This would be -5. Now, I did want to do some of our whole values so you understand. Hey, my greatest integer of 5 is going to be 5. It's going to be exactly the same. Think about that scenario with the McDouble. If I have $5, I can get 5 McDoubles. All right. What's the greatest integer of 8.9? Well, that would be 8. Again, I'm rounding down. How do you graph the greatest integer function? Well, let's think about the McDouble situation. All right, let's have X be the amount of money that I have in my pockets, and Y is going to be the amount of McDoubles I can get at McDonald's. Okay, so we got our McDoubles. Now, let's think about it. Let's think about the money here. Well, if I have $1 in my pocket, I can get 1 McDouble, right? 1 and 1. If I got $0, I should put that right here. If I have $0 in my pocket, well, guess what? I can't get any McDoubles. If I have $2 in my pocket, I can get 2 McDoubles. If I have $3 in my pocket, I can get 3 McDoubles. If I have $4 in my pocket, I can get 4 McDoubles, and so on. 5, I can get 5 McDoubles. So we kind of see how that goes. But let's talk about in between. Well, if I have $0, again, I said I can't get any McDoubles. If I have 75 cents in my pocket, guess what happens? I still can't get any McDoubles. Okay. So, but if I have $1 in my pocket, I jump up and I'm able to get 1 McDouble. So let's look at this interval between 0 to 1. Well, I'm all the way down here at 0 if I have less than $1. And it doesn't jump up to 1 until I get exactly $1. So there's going to be an open circle here at 1, 0. And then I jump up to 1 once I have exactly $1. Now, what happens when I'm in between 1? Well, if I got $1.40, guess what? I can still only get 1 McDouble. $1.99, I can still only get 1 McDouble. And again, the same thing happens. I'm going to still be at 1 as long as I'm in between 1 and 2. I won't jump up to be able to get 2 McDoubles until I have exactly $2. So again, that open circle happens at 2, and then I jump right up at $2. $2.50, we go on this same pattern. I stay at 2. So if you notice here, the greatest integer function is going to be just like our piecewise functions, but it's steps, because as I near each integer, I'm rounding down. Once I hit the exact integer, I jump up. Okay, I jump up to that value. So this is why this is called the step function. And notice this one would be the floor, because notice it's going down. We're rounding down to each one of those values, and then we jump up to the value once we reach it. Okay, so this is why this is called the floor function. Okay, we'll model another real world scenario. The number of songs that can be purchased for $1.50 each is based on the amount that's on your gift card. It's represented by the function the greatest integer of x over 150. Which graph represents this situation? Well, it's obvious that x represents the amount of money on my gift card. I'm going to be restricted by however much money is put on the card. So for instance, if I have $3 on my gift card, or F of, I'm sorry, not $3, but 350 on my gift card, okay? If I have 350 on my gift card, or F of 350, if I think about this greatest integer function, I am only able to get a certain amount of songs, even though it's over the 150 threshold. I can only get a certain amount. So let's see what happens here. Well, 350 over 150. All right. So we know that's going to be 2.333 repeating. Okay. And if I think about that, this does not matter, right? It doesn't matter because I can only get two songs, okay? So if you think about this idea in a real world scenario, you're restricted to the amount that's on your gift card. You can't go over that amount. So I would only be able to get the two songs. Now, what would happen if I wanted to get three songs? Well, I would have to have $4.50 to hit that threshold. Now, I want you to take a minute and think about this function. Think about the greatest integer function in this scenario. Look at your four graphs on your guided notes. Decide which graph makes the most sense in terms of this real life scenario. If you pick this graph, you are absolutely right, where X represents the amount of money that's on your gift card and Y represents your songs, or the number of songs you can buy. With that being said, we could do a test of this. Again, anything, if I have no money, right? I can't get any songs up until I get to the threshold of $1.50. Once I get to $1.50, I jump up to where I can get one song, and that remains the same until I get exactly $3. When I get $3, I can now get two songs, and that'll remain constant no matter how much money I have on my gift card until I get $4.50, and so on. Good job, guys. All right, let's talk about evaluating this. Okay, so we're going to use the equation f of x is x over 150 for our gift card scenario. So how many songs can be purchased with a $35 gift card? Remember, X is the number, or is the amount of money that I have on my gift card. So I'm going to find F of $35 to figure out how many songs I can purchase with that amount. So the greatest integer of 35 over $1.50. Now that equals $23.33333 repeating. But we know with our greatest integer function, we're going to round down. So I know I can only get 23 songs. Okay, I'm only going to be able to buy 23 songs. Now I want you to take a minute. I want you to answer the question to the right using the greatest integer function. Now, we talked about rounding down. Let's talk about rounding up. Okay, and what type of scenarios would we round up? All right, the least integer function is a function whose value at any number x is the smallest integer greater than or equal to x. So basically, we're going to round up. This is the rounding up function. When I denote the least integer function, notice the brackets are now at the top because I'm going to be rounding up. It's called the ceiling of x. For example, they have 3.578. That rounds up to 4.78 rounds up to 1, and negative 4.64 rounds up to negative 4. Again, be careful with your negative numbers. Well, let's talk about why or when we would use the least integer function. So the holidays are nearing and we're sending packages to our loved ones. Now here's the deal. A package costs $1 per pound or fraction of a pound. That means that if I have 0.25 pounds of a package, I still have to pay $1. Okay. When I go over a pound, I have to pay $2. So when X is the weight of our package, so that is the pounds of the package, and Y is the amount of money, let's use our least integer function. And remember, we're going to denote the least integer function by saying f of x is equal to the least integer of x, and our brackets will go to the top. So at 0 pounds, I'm not gonna be paying anything, right? Still paying 0. But when I get to 0.25 pounds, I'm gonna jump right up to $1. Okay. If I have 0.75 pounds, I still have to pay $1. If I have 1 pound, I still pay $1, but when I get to 1.25 pounds, I jump up to $2. Least integer function, okay, or the rounding up function. I'm going to round up. Let's take a second and let's evaluate the least integer function, especially when it comes to negative numbers. When I see it going to the ceiling, I'll know this is the ceiling or the least integer function when I see those brackets up at the top. So I know that I'm rounding up. So the value of negative 10 is going to be negative 10. Okay. Now, if I talk about the least integer of, let's say, negative 10.5. Again, I see that the brackets are going up, so I'm rounding up. So the least integer of negative 10.5 will still be negative 10. Again, rounding up function. Okay, so how does the least integer function or the ceiling function compare graphically to the greatest integer function? Well, let's look at it. Notice between each interval on the ceiling function, I'm at the higher values. So if I look at the McDouble scenario, if I have $0 or less than $0, I can't get anything, but once I hit $1, I can get the first item, right? Well, at this scenario, the moment I have a little bit of weight, I am charged for that first item. So this is how you see the difference here. We reach the ceiling or the max, okay, because we're rounding up, right? When our function is a little bit over that integer. So that interval between 0 to 1, whereas on the greatest integer function or the floor function, I'm right at 0. My ceiling function between 0 to 1, I'm at 1, okay? Because we're rounding up between each interval, okay? That's the difference. And you can see now why one is called the floor, because you're at the bottom between each interval, and one is the ceiling because you'll always be at the top between each interval. Now, I would encourage you to pause the video at this moment and try to do this real life situation where you have to pay to park. Write a function using either the greatest or least integer function and determine each one of these costs. Okay, let's see how you did. I have this scenario where I go and I pay $3 per hour or a fraction of an hour. Well, I'm definitely thinking the least integer function or that ceiling function, because if I just park for 30 minutes, I still got to pay $3. So if I have to write a function for this, I'm going to say that f of x is equal to 3 times the least integer or the ceiling of x. Basically, if I park for, say, half an hour or 0.5, x is my number of hours, okay? And y is going to be the amount of money that I pay, okay? I can now determine the price it's going to be depending on the amount of time, the amount of time that I am going to park. So if I look at this, if I park for 5 minutes, it is going to cost how much dollars? Okay, well, that's a fraction of a minute, right? So that's 5/60 of a minute, all right? So if I think about that, I'm going to be taking 3 times the ceiling of 5/60. Well, again, that means that I'm going to be rounding up, which means I'm taking 3 times 1, rounding up. And that means it's going to cost me $3 to park. If I look at the next one, 1 hour cost how much? Well, we know if I'm just going to plug in a 1 into that function, I'll still be taking 3 times 1, so that's 3. Now, 1 hour and 50 minutes. Well, now I'm going to be taking f of, and I'll just do a mixed number, 3, or I'm sorry, not 3, 1 and 5/6 hours, right? 50 over 60. And if I think about that, again, I use my ceiling function. And if I take the ceiling of 1 and 5/6, I know I have to round up. That's just going to be a 3 times 2. Well, 3 times 2 is 6. So I know it's going to cost me $6. Let's look at the next one, 2 hours. Well, I put that in the greatest integer function. That's going to be 3 times 2. That's also going to be $6. 2 hours and 1 minute. Again, we get the gist here that I have to round up. So this is going to be 3 times 3. So this would be $9. The next one, 3 and 1/2 hour. Well, I'm going to round up. So this is going to be $4. So I'm going to be taking 3 times 4, or I got to pay $12. Okay, let's figure out how to write a function when we have constant rates and then it changes. So the first scenario is our pay to park for $3 per hour, a fraction of an hour. Well, if I write that function, we did that. We said, hey, f of x equals 3 times the least integer of x. Okay, so now let's talk about what do we do if we have a situation where we pay to park $8 for the first hour, but then $3 for each additional hour or part of an hour. Well, how we're going to write this equation, and it kind of makes sense here. We'll still have the same variables, right? We got our variables where y is the cost and x is the amount of hours that you park. Well, I start off in the beginning I have to pay $8. Okay, $8 as soon as I go right into the parking lot. Okay, so that first hour is going to be $8. Added to that is $3 for each additional hour that I park. So I'm going to include my 3 times my ceiling function, but this time I got to think about this. I am going to not just have X inside of my ceiling function, but I'm going to subtract. All right, guys, that's it for the least and the greatest integer functions. So we now have added on to our piecewise functions. We now have our step functions.